All right, so this question has a lot going on. We're to identify whether the type of growth pattern that is shown by each pattern. We are to find the fifth step in each of these, so the total number of squares in the fifth step, and we're to write expressions for each. So as usual, I will start by just looking at the total number of squares in each, and I'm just going to do that on a table. So for pattern A, I'm going to use my X to represent my step number and my Y to represent the total number of squares in each pattern. So for step 0, there are 0 squares. In step 1, there is just 1 square. In step 2, there are 4 squares. In step 3, there are 9 squares. And one thing I'm noticing just right off the bat is that these are squares. This is a 1 by 1. That's a 2 by 2. This is a 3 by 3 square. And so I'm going to go ahead and based on the pattern, it would mean that step 4 would be a 4 by 4 square. So step 4. Seems like it would be a 4 by 4. So a 4 by 4, that would mean 16. And step 5 would be a 5 by 5, which would be 25. Now let's examine how our numbers are changing as we move from one step to the next. So that's a plus 1. 1 to 4, that's plus 3. 4 to 9, that's a plus 5. 9 to 16, that's plus 7. And 16 to 25, that's actually a plus 9. And so we're noticing that there's no constant rate of change. However, the rate of change is changing at a constant growth by adding 2 each time. So from 1 to 3, that's a plus 2. From 3 to 5, that's a plus 2. From 5 to 7, that's a plus 2. And from 7 to 9, that's a plus 2. So we're noticing that there is this is going to be representative of quadratic growth. So this is showing quadratic. Let's clean that up a little bit. And then for quadratic growth, we notice that, there are squares. So squares are growing and increasing in size. And that's going to be true for the 4 by 4. So they're growing and increasing in size. So it's quadratic growth. And this is because we have the rate of change changes at a constant rate. So rate of change changes by a constant value, and that is plus 2. Now let's look at pattern B. I'm going to construct my table of values. All right, so X represents the step number, Y represents the total number of squares. So for 0, there's 1 square. For 1, there are 2 squares. For 2, there are 4 squares. For 3, there are 8 squares. So it looks like we are doubling the number of squares each time. 1 times 2, that's 2. 2 times 2, that's 4. 4 times 2, that is 8. And so for our fourth step, that's going to be 8 times 2, that is 16. And for our fifth step, it's going to be 16 times 2, which is 32. All right, so we've established the total number of squares for the fourth and the fifth step. And because there's a constant growth factor, so we have a constant growth factor here, of times 2, we know that this is showing exponential growth. So we had 1, 2, 4, 8. Now, one of the things they asked us is which is growing faster. And when we look at the numbers, you notice up to step 4, 4 they have the same, but after step 5, we're noticing that pattern A has 25 squares, whereas pattern B has 32 squares. So clearly just examining what's going on after the fifth step, exponential is going to get bigger. So we can say that pattern B is growing faster. It shows in step 5 for each pattern. There we go.